So thank you everyone who's here today. And my name is Dr. Lauren Weidner. I am an assistant professor of forensic science at ASU New College on West Campus. So my talk today is titled Thinking Outside of the Box, Partners in Unexpected Places. So I do have a disclaimer that this presentation does contain several graphic images, just as a heads up before we get started. And the reason for that, so as I had mentioned, I'm assistant professor, also the forensic science program lead, and I'm a board certified forensic entomologist. So I thought it was fitting to show two photos of currently how I've been working and teaching with the last year due to COVID. So I'll either be on campus, always wearing a mask, or at the bottom, I have some pets at home that like to participate in my lectures when I'm having them. Just a little bit background about me. I did my undergraduate degree in forensic science at John Jay College of Criminal Justice, and then followed that up with my PhD at Rutgers University. The overview of what I'm going to talk to you guys today is the building blocks of forensic entomology. So that is where my focus is and what I do. So to fully understand how we're going to tie that in with different communities, I want to make sure you guys have a good understanding of what it is. I'm going to talk a little bit about the research that I'm doing at ASU, because that's really how these several of these community ties started, and then the different ways in which we're working with the community currently and some of our future plans. Forensic entomology, in case you guys are not familiar with this, the word forensic means the application of scientific methods and techniques to the investigation of crime, whatever the scientific field may be. Entomology is the study of insects. So these are from the 2 degrees that I obtained. This is the main focus of what I do. I work with the insects that are associated, whether they're with remains or used in different types of legal investigations. So I always like to start when I kind of give this introduction to what forensic entomology is and how we use it, simply going over what makes an insect, just because we'll see them, but we don't really think much about what classifies them that way. So I did a nice general search of just insects through Google, and you're probably familiar with some or most of these insects: an ant, ladybird beetle, butterfly. We have a grasshopper on the top and then a dragonfly on the bottom. And as you can probably tell, just by looking at these images alone, insects are really diverse. So I wanted to share some of my favorites with you to get started. This is an orchid mantis. So the insect is actually right there in the center. It's a type of praying mantis that mimics an orchid. This is something known as a scorpion fly. As you can see, based on its genitalia, it looks like a scorpion. This is known as a Brazilian treehopper. And my favorite insect of all time is this little guy right here, known as a giraffe-necked weevil. And I just love sharing diversity of insects with individuals because I feel like we don't give them enough credit when we're looking at them most of the time. So to be classified as an insect, this is also really important. They have to have 3 body segments. So as you see here on this generic picture of an ant, a head, a thorax, and an abdomen. And also something that's really important, they have a max of 6 legs. So spiders, you have 1 too many sets. And they also have an exoskeleton, so their strength is on the outside of their body, unlike us, where our skeleton is found within. Therefore, these guys right here are not insects. I'm personally not a fan of most of them. They have too many legs for my liking, but it doesn't mean that we can't use them in investigations. It's just not what I'm referring to when I'm talking about insects. So forensic entomology, as I had mentioned, is the use of insects in legal investigations, and we can use them in a variety of ways. There are 3 main areas of forensic entomology: stored products, urban entomology, and medical legal entomology. The bottom one, or the last one here, is what I mainly focus in, but I'd like to share with you what they all are. So stored products are when insects infest food, whether they're stored in your home, a warehouse, or on a store shelf. They can infest usually dry materials and fruits or vegetables that are starting to go bad, so grains, flours, oats. And the typical culprits tend to be certain types of beetles, moths, or flies, as you can see here in these images. I do always like to talk about what you can eat though, because insects can be found in food. So the FDA has a list of what insects can be found in what ingredients or food products. And I just like to use pizza as an example, just to give you guys some background with this. So flour can have an average of 75 or more insect fragments per 100 grams. Sauce, so like a tomato sauce, can have an average of 30 or more fly eggs per 100 grams. And oregano can have an average of 300 or more insect fragments per 10 grams. And if you think about that, it's a plant outside, so it's probably already covered in insects. However, not all insects are accidental in our food. The next time you're having a strawberry or a raspberry flavored item, I want you to take a look at the ingredients. And if you take a look on the back, I want you to take a look at what it's colored with. So a lot of things can be colored with red 40, for example. But if you ever notice something that says colored with carmine, that actually means it's colored with insects. So this is a type of insect known as a scale. And certain species, when you crush them, produces a red color. So that is one of the ways that we dye our food a certain color. This was actually a civil case where Starbucks had their strawberry and cream frappuccino, I believe it was, and it was dyed with carmine or colored with carmine, and that's the carmic acid from the insects. Whoops. And therefore, it wasn't vegetarian. So just something to think about. People also now use beet juice for that dye. But more commonly, insects are becoming used as a protein source. So cricket powder has recently made its way onto the shelves. This was just a quick search I did on Amazon. I remember when this first started being a thing, probably five to 10 years ago now. So that's just a little bit about stored products, but at the same time, the insects we can eat. So urban entomology. When I'm referring to this, I'm referring to insects in structures that we don't want to be there. Termites, ants, cockroaches, bed bugs, all of those that you hope you never see in a building that you're in. And the way we can use these for investigation, so the two images here on the left and the center are termite damage. And the way we could use that in a forensic context would be you buy a home, you're there for about a month or two, you're doing some renovations, and all of a sudden you notice you have extensive termite damage. By looking at the biology of this insect, we now know that that termite damage has been there for months before you bought the home. So now it comes down to, did the previous owners know and not tell you? Did they not know? Was it missed in an inspection? All of that. So that's a civil situation where there's no criminal activity per se. The image here on the right is actually from a model who sued a hotel because she had stayed in a hotel and claimed that she had gotten bitten by bed bugs. And because of that, she could not do her job. So this is another example of a civil investigation. Medical legal entomology, this is directly used by law enforcement. We use this in death investigations, abuse and neglect cases for animals, the elderly, and children. When we talk about it in this sense, the information that you can get from insect evidence varies. You can get so much depending on what insects are available, but typically we will use them to help determine how long remains have been present, if a body has been relocated, the presence of drugs or toxins in an individual or the body, and a lack of insects can even provide information as well. And there is way more than this, but I just had to do the main ones to make sure we don't go over time. But I'm going to talk a little bit more about this. So why are these insects beneficial? I just gave you a list of kind of what we can get from them, but why is that the case? Insects can arrive quickly to remains. They're found globally. We use something known as a time of colonization. So we look at their development to determine how long they've been there. And they are holometabolists, which means they undergo a complete metamorphosis and they have different life stages that we can quantify the amount of time they spend in each and work backwards. Think of a butterfly, how it has the caterpillar, chrysalis, and then adult butterfly, and they look nothing alike. That's the same with the flies that we use. And their growth is temperature dependent, which means the warmer it is, the quicker they develop. The colder it is, the slower they develop. So what can the insects tell us? I'm going to cover 3 questions that we can answer using them. Where is my first example? And we do this by understanding their distribution and their preferences. So here, for example, in Arizona, I'm just going to simplify this. There are two fly species, right? We have this gold and this kind of maroonish brown one. Up in Montana, we have this gold species, but we have this black species. So looking at this map, we can tell that the gold species covers north, south. It's much more widespread. Whereas the black species is up in Montana, so a northern region, and the maroonish brown one is found in a southern region. So say you're in Montana and they discover a body on the side of the road. There are insects on it and they start to rear those insects out, and this is your species population. What we know right off the bat from that is that body is not originally from that area. So that's one of the ways we use insects to help determine if bodies have been moved or relocated. Another question we answer is how. So insects will colonize in specific patterns. They typically go for orifices on the face, so eyes, ears, nose, and mouth, anything that has a moist, protected environment. And then as they feed, they will work their way down through the body. However, if wounds or trauma are present, they will colonize those areas, which can indicate to us that something else was going on. So this is an example for something we had done for my class, and this pig specifically had had an anal prolapse, so it had trauma to its hind region. And what you're seeing here is that's actually colonization by insects. When is probably the question we get asked the most, which has to do with time of colonization, as I had mentioned previously. And this is how long have those insects been there? And what that relates back to is known as a minimum postmortem interval. It's the period between death and corpse discovery. So how we do that is specifically working with insects' development cycles. Blowflies are commonly the insect we run into the most that are our initial colonizers. And these are the four main stages of their development: eggs, larvae, pupae, and adults. We determine what stage they're in, how much time it takes for them to reach that stage, and ultimately work backwards. So just so you can get a little bit more familiarity with these insects and their life stages, as I'm sure you've probably never looked at them this close, or for the most part, probably not. These are what blowfly eggs look like. They're very small. They're usually laid in clusters. They're about 1 to 2 millimeters in size. They kind of look like tiny little pieces of rice. Eventually, the fly will hatch out into a maggot. So maggots are basically just baby flies. And this is what they look like. Now, I like to show the image on the left because people usually think those two dots that you're seeing are eyes, and that's actually not the case. This area is actually their head region. So the black that you're seeing there are their mouth hooks. That's how they feed. And the end that you're seeing there, those are known as their posterior spiracles, and that's actually how they breathe. So while maggots feed, they simply submerge their face, for lack of better words, into their food source, continuously feed, and just breathe through their butt. The blowfly pupae, so when they're done feeding, they've fed to their heart's content, they're going to then pupate. They usually crawl away, and the pupa is found within a puparium. So the outer layer of basically that last maggot hardens, and the insect shrinks inside and develops to an adult fly. This is an example of what pupae look like. People often mistake them as rat droppings, so they can be missed at investigation. So now that you kind of have a little bit of background, and I apologize if I went through that quickly, but I wanted to make sure that we had time, how does forensic entomology look in Arizona? Unfortunately, it is basically non-existent. If you take a look on the left side of the screen, those are the years that research was conducted related to forensically important insects or blowflies specifically. So, and a lot of this work, the 30s through the 60s, was really looking at filth flies in general. As we started to urbanize areas with cities, you had farms with livestock. The one study there with an asterisk was the only paper I could find, and it was actually an unpublished master's thesis that looked at blowflies from a forensic point of view. From that work, 10 species of blowflies were collected. And remember, blowflies are usually the first insect to arrive to remains, making them extremely important. However, in 1982, so right there at the end of that work, a new invasive species moved up into Arizona, which really has had some impact on our native species. So with this work being so non-existent, what are we doing in my lab? So I joined ASU about 2 years ago, and these are some of the projects that we're working on. We're looking at blowfly biodiversity in Arizona, how they're colonizing, so the order that they're arriving in, how soon are they arriving. We're looking at larval morphology, so helping to identify the insects while they're in this larval stage, and their development. All of this information can really help our law enforcement and our forensic practitioners. So to complete this, we have to have the basic forensic entomology needs known in an area. This includes distribution information, habitat and seasonal preferences, and developmental information of these species. So I want to start just by quickly going over a project that I've done with several students in the last year or so, and it was super informative and it's been so wonderful. And it's what species are found when. We need to understand when these insects are present so they can become useful for our forensic investigations and our law enforcement. So this is what we did. If you guys are not familiar with Arizona's West Campus, it's a beautiful campus. I'm really fortunate to be there. It's not too big. So this is the kind of the perimeter with the roads. And where you see those yellow triangles are where we placed our traps. We did this for a year, so from June 2019, right up until the start of when the pandemic hit. And we placed out 4 traps every week, which had 60 grams of bait. And my bait in this situation are different types of liver. So we use organ meats, beef liver, pork liver, chicken liver, and then we mix them all together. And that's really important because this is usually something we get from a grocery store. We rotated their location each week. We kept them out for 24 hours. And this is what the trap setup looks like. It's not very complex. It's very easy to do. It's a Ziploc bag with a cone trap. We have a food source inside and we hang it up. And this was our results. I know these species names aren't going to mean anything to most of you, and that's totally fine. But what I really want to point out is we collected 8 species in just this first year in just the Phoenix area. You, if you're native to Arizona, are probably more familiar than me with the complete diversity of the state. So this was really important because now we're starting to learn what are our key species in this area that we need to focus on to help this law enforcement community. And these 3 here were what we determined to be most important, and there's very little work on 2 of these species. And this is just a quick look. As you, again, you guys are probably familiar with being in Arizona, those hot temperatures that kind of come through in the summer. And we noticed that we were actually losing our blowfly populations during that time. It was just, it seems to be too hot. So that's something else we're also looking into. So how hot is too hot? This brings us back to a basic biology question of thermal biology. What are their limits? What's their maximum temperature? And what's their minimum temperature? It brings us back to ecology as well, right? This is a very urbanized area. Phoenix is one of the fastest growing metropolitan urbanized kind of areas that there are, producing a lot of heat. So we want to know, how would this compare to other portions of the United States? And I've actually been fortunate enough that neighbors where I live, they have some land, and that they're willing to actually get involved with my research projects to allow me to use their land, which is just amazing. But 2 of the development studies that my students have been doing have been great. One of them is looking at the effect of fat content on the development of a blowfly species, and another one is looking at different food sources that law enforcement can take into the fields with them to collect entomological evidence. The last thing we're working on is larval development, as I had mentioned earlier, and these are just some images that my students have taken that I think are wonderful, so I always try to kind of sneak them in wherever I can. But how does that tie to the community? So COVID has definitely taught me a lot, and it's actually taught me that I can reach out to different communities in a way I never have before. So when I first thought about community, I wanted to know what was the real definition of it, right? And it was really interesting because I found this really nice explanation that communities can be defined basically by 5 different points of view: interest, action, place, practice, and circumstance. So if you have the same interest, if you're trying to bring the same type of change around, geographic boundaries, so like the street that I live in, my neighborhood, my community, practice, my field, my scientific community, or circumstances. This one for me, I think of some type of, natural disaster or chaotic event that brings people together. So I decided to work with the community a little bit differently than I ever have before. So the first community that I'm going to talk about here is our law enforcement and our forensic practitioners. And this is a community that I've worked with throughout my time being a forensic entomologist, but being new to Arizona, it's been limited. And something I think that's really important that people might not be aware of is insects are actually being used to help exonerate wrongfully convicted individuals. So there's something known as the Innocence Projects that works on this. There's the Arizona Justice Project. The top case here that 48 years later, a man was wrongfully convicted of a crime in Canada, and he sat in prison for 48 years for something he did not do. And a woman actually in Las Vegas was wrongfully imprisoned for 17 years. So what I'm trying to do with these insects is reach the point where we're not having wrongful convictions. We're stopping that prematurely. So hopefully these insects can provide that information. And one of the ways we're doing this is providing forensic entomology training to the law enforcement and forensic practitioner communities. So different police departments, medical examiners' offices, anything that can be involved in that way. Because I need that relationship with them, right? I'm trying to help them, so I need to know what they need. So this is the first community, and I feel like it encompasses several of the different points that we mentioned earlier about actions and the same work interest. So this was the first community that I've been working with that I hope to continue and hopefully expand beyond just Arizona. But I want to step back for a quick minute and just discuss my research materials. As I had mentioned to you earlier, we use a lot of organ meats, muscles, and animals. So usually we'll use stillborn pigs if we can get them, or we have to go to pig farms. But I was looking around, especially when COVID hit and everyone was kind of in this lockdown situation. So a colleague of mine said, well, what about social media? I'm not the best with social media, but I'm getting better. So community number 2, I went to Facebook, and there's actually a group page called Arizona Meat Pigs. And I did probably what an awkward scientist would do. And I did a post. I said, hey, everyone, I'm a forensic entomologist in this area. This is the work that I do. Pigs are common for what we're looking for. If you ever have some that, so piglets a lot of times are either stillborn or they'll get crushed, or they'll sometimes need to put older pigs down that they can't sell. So instead of having them waste this and just having to get these animals out, I thought, hey, let me know if this could work for you. And within a couple months, we started working with local farm to basically produce their waste while processing. So they would process what they want for human consumption. And then I pretty much took all of the organs that they didn't want. We ended up getting about 50 pounds of organ meat, which was amazing because that's going to basically allow for about 3 or 4 undergraduate research projects. And unfortunately, they weren't able to be here today. This was the Bright Family Farm. But I just wanted to show you that the interactions that I received, right? Like I had no idea how this was going to go. I just put this post out and hoped for the best. And after I met with them and they had all this organ meat for me, they said, let me know if they're good for you to use. It's the first time doing something like this, but I'd rather them go to use than thrown away. And again, same thing. I would just love to see as much of the animal go to use instead of trash. And this actually led to another colleague or friend of theirs doing the exact same thing with more pigs. They were processing it. They were really interested in not just wasting these other organs and parts. So I happily said, yeah, I'll work with you on that. Just recently, I had another local farmer reach out to me. So that was really exciting because it's allowing us to reduce this processing waste when the animal is being used for human consumption, that there are obviously parts you're just not going to consume. So we stuck with this, and I started working with another student. So I wanted to just throw some titles out here. How a corpse-loving fly can help catch rhino poachers, and wildlife forensic entomology. So the way that we're using these insects in criminal investigations with humans, we can actually do it with wildlife. And what's so great about these insects, as I mentioned earlier, they're everywhere. Doesn't matter whose land you're on, private, public, they're there. If there are animals there, they're going to be there. So I started working with a student doing a wildlife forensics project. And we needed the same thing. We needed to know what insects are where, who's coming, or what flies are coming to wild game meat. So she's based up in northwestern Arizona. So I said, okay, what wild game do you have up there? She said, well, what we have in this area is javelina. So I said, okay, let's see what I can do with this. Back to Facebook I went. There is an Arizona javelina hunting group. So I was like, all right, I'm gonna do that awkward scientist thing again. I did a post. Hi, everyone. This is what I'm doing. We're trying to do a wildlife forensics project, and we need javelina in our bait. Please let me know. And I wasn't quite sure what to expect, but it was amazing. Everyone was super supportive about this. These are just some of my comments, that they were excited. They want to see the results, what I was looking at in this project, really getting that engagement. It was wonderful. And I ended up meeting with 4 hunters who, same thing, they process them for their own purposes, but then they have leftover pieces. So this is actually the project. We were able to gain about 15 pounds of meat, which will allow, this is the graduate student, to do her project through to this fall, which is when I'll kind of work out with them again. And the response I got from them was just so incredible, because they were so interested in it. And they were asking if I needed other wild game, or if they ever had questions, could they ask? And I said, absolutely. It's just so great, again, to reduce that waste. So I was really excited about this. This was just a little video from when we had done this. So this is our trap up here. So we obviously were bringing in more than just insects with this one, but I am an animal lover at heart and always have been. So I loved this video. So I just wanted to share that with you guys. The next community. So yes, I am a forensic entomologist, but entomology doesn't just have to deal with insects and remains, right? There is a bunch of other things going on. So there's something known as National Moth Week. And this is where we go out at night with local communities. It doesn't matter if they're little kids, adults, you want to do it through different types of schools, that's totally fine. We go out at night with certain equipment and we look at moths, we photograph them, we collect them, introducing everyone just to the insects around them. So my community for here is anybody interested in insects. It does not matter their age. And an additional way we do this is something known as a BioBlitz. I'm not sure if any of you have ever participated in one of these, but they can last a day, a weekend, a week, and you pretty much go out, and BioBlitzes can be specific. So mine would be with insects. In this picture here, there's actually a beetle on the tip of my finger. We were doing a night collection. And I've done this again with all ages. You can do elementary school, middle school, high school, college, adults, it does not matter. And it's just to get that interest in insects, see their benefits, see what insects are actually around you. So this is something else that I'm also really interested in. And they had mentioned service learning earlier in their introduction today to this meeting, which I thought was so great, because service learning is something we're trying to get our forensic students involved with. So not necessarily directly related with insects, but bringing their knowledge to different communities at different levels, which I just think is something that's wonderful. So with that, my last community that I'm going to talk about is our future community partners. So we have 2 main goals. It's reducing food waste and supporting insect biodiversity. And the food waste, we can actually reduce it, and we're aiming for different types of partners here. Grocery stores, bakeries, farmers. We're actually looking at using these materials with different insects to reduce food waste. And then we also want to support local insect biodiversity, gardeners, if you have an urban garden, how that works, what these beneficial communities are. And what I think is so nice about that is insects create their own community, and we are surrounded with them and living with them, every day of our lives. We necessarily don't think about them as our own community unless you're really focused on bees and pollinating. But it's something that I think we really need to start thinking about. And I think that this will allow for a lot of really, really good and innovative future opportunities. So I want to thank everyone for their time. I know we started a little bit late, but I wanted to try to catch up there and wrap up on time. I always just like to throw in a picture. That's actually my lab tech who does amazing work, and he's always behind the camera. So I always try to sneak in a picture when I can. But I want to thank you guys for your time, and please let me know if you have any questions, and I will be happy to answer them. So let's see, I actually just pulled up the Q&A chat. So I just saw kind of a comment there about collaboration around javelina corpses. You can do anything these days. So I see a question, I'm just going to read it in case anyone's not there. Are you working with waste not and university sustainability practices? They're looking for interesting, innovative ways to collaborate with ASU faculty and community partners around food waste. So I actually just started working with food waste that has been produced from humans, so not necessarily processing. I actually had an undergraduate come to me in environmental sciences about this, using insects to reduce food waste, and a colleague of mine has recently started a company on this, and currently nobody in Arizona is working on this. So we are actually planning to work on that for her senior thesis. But I have been in touch with the sustainability group here at ASU, and I've just started getting involved with them. So hopefully that will head that way. Are there any other questions, comments? If there are not any comments, I think I'm good. As I had mentioned, I'm not very good with social media, but my friends and colleagues have suggested I get Twitter and Instagram, so I'm working on those.